after 1 week, I just would like to know, like, whether anybody remember what we are basically discussing in data mining. What are we discussing in data mining? At least the headings. I'll not ask you what is what. What have we discussed before your CPS classes started? Nobody remembers, huh? At least which unit are we discussing? No answer, no reply for anything. Unit 2. Okay, so Unit 2 was all about association rule mining. Am I right? Association rule mining. Then what are the 3 algorithms that we had discussed as a part of association rule mining? First one, we discussed about a priori algorithm for generating frequent patterns using candidate generation. Then it had some disadvantages, so which we could overcome with the help of your second algorithm called frequent pattern growth algorithm. That was an algorithm for mining the frequent patterns without candidate generation, right? Okay. Then we also looked into another algorithm called ECLAT. What was ECLAT all about? What was ECLAT all about? Mining frequent patterns in a horizontal data format. Okay, so that was what we discussed in the last class. Okay, so when you have data in the, generally we have data in the horizontal layout for your a priori or your frequent pattern mining algorithm. So then in case you have a vertical data format, a vertical layout for data, like what is shown here, okay, then we go for this equivalence class transformation algorithm or ECLAT. Okay, it's also called vertical a priori. Okay, so that's what we have discussed. Okay, so now moving on to the last topic of this unit. Okay, so this is what we have discussed so far. These topics are over. We're moving on to the last topic of the second unit, mining closed frequent patterns and max patterns. Mining closed frequent patterns and max patterns. So closed frequent pattern, we have what is called a closet, closet pattern mining. A max pattern, we have, the name is what we call it as max miner. Max miner mining and closet mining. Okay, so let's try to understand what are these terminologies. Okay, so how many have joined right now? 36. Only 36 students have joined. Okay, right, so let's try to understand these 3 terminologies. The first one is what is called frequent item set. Second one is what is called closed frequent item set. And third one is what is called maximal frequent item set. Okay, closet and max miner. Okay, closed pattern mining, closet. Maximum frequent pattern mining called max miner. Okay, so like recent studies in the field of data mining, okay, so that has proposed this particular interesting alternative, we can say. So far we have looked into only frequent item set pattern mining. Okay, so now we are going to look into these 2, the second and the third one. Okay, so that is mining frequent closed item sets and their corresponding rules. Okay, so that is actually the same power, just like association mining, and again it will reduce the number of rules also. Okay, because the set of frequent closed item set will generally be much smaller than the set of frequent item set. Okay, so it is easy to deal with. It is easy to deal with. So that's the reason why we go for this closed frequent set item mining and maximum frequent set mining. Okay, so now let's try to understand these terminologies. Okay, so the first one, frequent item set, all of you know. So a frequent item set is an item set whose support is greater than some user specified minimum support or your min sup. So minimum support will be specified. If your frequency is more than that, then you call it as a frequent item set. Otherwise, you ignore it or cancel it out, remove it from further transactions. Okay, then what is called a closed frequent item set. Okay, so an item set is closed if none of its immediate supersets have the same support as that of the item set. Okay, then again, maximal frequent item set. I'll give you an example for it. I know when I just told the definition, it is not clear. I'll give you an example. We'll work out an example and find out what is a closed frequent item set. So I'm just first reading out the definitions. Okay, so next is maximal frequent item set. Okay, an item set is maximal frequent if none of its immediate superset is frequent. Okay, so just we had a glance at these definitions. Okay, so before we start working out an example on all these three, the first one, of course, we know. Okay, I'll just tell you an interesting property called downward closure property of frequent patterns. Okay, so this is an important thing or an interesting thing to note. Okay, so what it says is all subsets of any frequent item set must also be frequent. Okay, for example, if milk, bread, butter, okay, so if these three things, if it's a frequent item set, then the following items are also frequent. That is the subsets of it. Milk is frequent, bread is frequent, butter is frequent, milk butter is also frequent, milk bread is frequent, and bread butter is also frequent. The respective subsets are also frequent. Okay, so that's what this tells you. Okay, so now the question comes, why do we need this closed and maximal item set? Okay, so you can see from this figure. So the superset is actually the frequent item sets. Okay, so the closed frequent item set is a subset of this frequent item set, and maximal frequent item set is a subset of closed frequent item sets. Okay, so these closed frequent item sets about which we are going to discuss now. Okay, so that is actually when useful when we have huge amount of data is used in association rule mining. Okay, so there is an interesting relation. For example, if the length of a frequent item set is k, okay, so then by your downward closure property, what does your downward closure property tell you? Subset of any frequent item set will also be frequent. Okay, so the subset of all these things was also frequent. Okay, so according to this property, if the length of a frequent item set is k, okay, so then by this downward closure property, all of its 2 to the power k minus 1 subsets are also frequent. Okay, so that's what your downward closure property tells you. Okay, so when the computation is very expensive and there is no interest to find additional subsets, okay, so in such case you can avoid it by frequent item sets with the maximum length. So that is what is called a max minor. Okay, fine. Okay, so uh, actually one disadvantage with your maximum frequent item set is that even all its subsets are also frequent, but then we will not be knowing their supports. Okay, because if you don't know the support, it is of no use for us, because for mining rules support information is very, very important. Okay, so that's the reason why we have this closed frequent item set mining, and that is the reason why it is being more preferred when compared to your frequent item set. And again, it will be lesser in number when compared to your frequent item set. Okay, so now we'll work out an example. Okay, so and compute all the three, your closed frequent item set and maximum frequent item set. Okay, so make a note in your notebook, not just looking at this. I want all of you to write it down in your notebooks. Okay, so we have 5 transactions out here. We have 5 transactions, T1, T2, T3, T4, and T5. 5 transactions are there. So, and in each transaction, a list of items are also being given here. Okay, so the minimum support is 3. So you need to find the frequent items closed items and maximal item set. Are you listening? Are you listening? Yes or no? So shall I mark absent for everyone then, if nobody is listening? Yash Rai, are you listening? Okay, no response. So let me mark him as absent. Nishok? Nishok is listening?
Yes, ma'am.
Yes. Why no response from anybody in the class in the mid-afternoon after having a lunch? Everybody is sleeping, huh? Those who don't respond, I'm not giving attendance today. Yes or no, some response should come from you. Okay, so these are the 5 transactions which we are considering, and we're going to find out the frequent item set, closed item set, and maximum item set. So the first step, you take the individual items and their support count. Okay, so all the items, that is, you have items A, B, C, and D. Okay, they are all frequent. Why? Because the minimum support count is 3. Can you mute the microphone? Somebody's unmuted the microphone. So please mute the microphone. Here. Who's that? You don't listen in the class. Leave it. Nishok? Nishok, you mute the microphone. Yeah. Anirudh, just inform Nishok to mute his microphone. Okay. Fine. So first step, you list down the individual items, write their respective support count. Okay. And all of them are suitable candidates for the next round because everything is satisfying the minimum support count. Minimum support count is 3 and there's nothing which is below that. Okay. Support count is greater than or equal to the minimum support. Okay. So now, just like a priori algorithm, so from the one item set, we generate a 2 item set combination. Okay, so we are generating a 2 item set combination. Okay, you can see here AB, AC, AD, BC, BD, and CD, and you write the respective count for it. So these are the counts. Okay, so now, now we need to. Is there any item which doesn't satisfy the minimum support count? No. Okay, so now let's see. No, our minimum support count is 3, right? Okay, so there is one item called AD. AD is not satisfying the minimum support count. So this can be eliminated. Okay, so this is having a support count of 2. Okay, so since our support count is 3, this can be eliminated. So next we have to see whether the item sets are closed or whether it is maximal item set. Okay, so let's start with the item A. Okay, you start with the item A. What is the support count for A? What is the support count for A? Can somebody tell me? What is the support count for A?
3, ma'am.
3, yeah. Support count for A is 3. Okay, so then you write the immediate supersets of this particular item. Okay, so you write the immediate superset. So what are the immediate supersets? Okay, you have the supersets of A as AB, for which there is a support count 3, then AC, for which it is a support count is 3, and AD, which is a support count is having 2. Okay, so this it's basically the support count what is being given here in the bracket. So the immediate supersets of A is being given. Okay, so the count A's count, that is 3. Okay, it is not greater than its immediate superset. Okay, immediate supersets count is 3, 3, and 2, and here it is 3. Okay, 3, and here it is 3, 3 and 2. Okay, so it is not greater than its immediate superset. So it is not closed. Okay, for example, if this was 4, then I can say that A's count is greater than its immediate superset's count, and that can be treated as a closed item set. So in this case, it is not, so it is not a closed item set. Okay, then next is maximal frequent item set, whether it is a maximal frequent item set or not. Okay, so what is the definition for a maximal frequent item set? What it says is an item set is maximal frequent if none of its immediate superset is frequent. Immediate superset is frequent means that it has a minimum support. Okay, minimum support count. Okay, so here A's immediate superset. Item sets are present in minimum support count. See, this minimum support count is 3, so that is present here also. So A is not maximal. Okay, so minimum support count is present in the immediate supersets, so it is not maximal. Then you take the next item. We have completed with the first item. Then take the second item, B. Okay, B, the support count is 4. Identify its immediate supersets. Immediate supersets. So B's count is not greater than its immediate superset. So 4. Here it is 3, 4, and 3. So it is not closed. Same way in B, immediate superset. Item is present with the minimum support count 3. See, minimum support count is available here also. So it is not maximal. Okay, so can you identify for the next next two items, A, B, I have told. Tell me whether C and D, we have 4 items totally, right? Identify whether C and D is closed and maximal and tell me. What will you do next? You will take up C. Then generate the immediate superset of C. Okay, and see whether the count is greater than its immediate superset. If count is greater, then it is closed. If it is not greater, it is not closed. Same way, do for D also. What about C? Is C closed? Can somebody who's working out tell me whether C is closed or not?
Yes, ma'am, C is closed.
Closed. What about maximal? Is it a maximal item set? Is it a maximal item set? Very good. C is a closed item set because the count is 5 here. That is greater than its immediate support count. Here you have 5, here you have 3, 4, and 2. So this is definitely greater. So it is closed. But it's not maximal because the minimum support in C's immediate superset item is present with minimum support count. That is 3. 3 is here. Minimum support count is there in its immediate superset. So it is not maximal. Okay, it is not maximal. Then what about D? So for D, support count is 4. It is not greater than its immediate superset. It's actually equal to. You have 2, 3, and 4. So it is not greater. So it is not closed. So again, there is a superset with a minimum support count value that is nothing but 3. So it is not maximal also. Okay, so we have first completed the first round. Okay, so next, going on to the next round. Okay, this is just like what you're basically doing is you're generating the 3 item set using the join and prune property of your a priori. Okay, so check whether the 2 item sets generated are closed, frequent, etc. Okay, so you are generating the 3 item set. Then you have to check whether whatever 2 item sets, whatever you have generated so far in the previous step, what are the items generated? You have generated AB, AC, AD, BC, BD, and CD. Okay, so whether that is AD, anyway, it is not frequent. This can be warded off because it is not satisfying. Okay, so this can be removed. Okay, so you take first AB. Take the first 2 item set AB. So generate its immediate supersets, ABC and ABD. Okay, check whether its count is greater. So it's not greater, so it's not closed, it's not maximal. Minimum support is coming in the right hand side. Then take the next item. After AB, the next item is AC. Okay, so take the next item. its support count. So this is also not closed, not maximal. Okay, right hand side minimum support is coming. Okay, so then AD, AD is 2. 2 means it is not even satisfying the minimum support, so it is not frequent. Okay, so it is not frequent. Okay, so next you take BC. You need to look into all the 2 item sets. Are you all working out? Are you all working out? Or at least listening? Vitun, are you working out? So Vitun, no attendance today. Yashrai, no attendance today. Okay, some response. Because, okay, yes, ma'am, fine. Okay, then no issues. Right, okay. Then BC is not closed. Sorry, BC is closed. You can see here. So BC's count is 4. That's greater than its immediate superset. So BC is closed, and whereas BC is not maximal because minimum support is coming here on the right hand side. Okay, then take BD. BD and its immediate supersets. Okay, this is not closed. It's not maximal. Okay, then come to CD. All the various 2 item sets I'm considering. Whereas here it is greater. So it's 4, 2, 3. 4 at the left hand side and 2 and 3 at the right hand side. So this is greater. So it's closed, but it's not maximal. Okay. So then anything else is there? Yes, we do have. Okay. That's it. I think we considered all the 2 item sets. All the 2 item sets are being considered. Okay, then moving on to the next step, 4 item sets. 4 item sets, you can see you're getting a count as 2. Okay, so this is less than, it is not satisfying the minimum support. So this is not frequent. You can straight away write that it is not frequent. Okay, so if you generate the immediate superset, this is closed and it's maximal. Okay, but then this is not frequent. It's a support count is 2. It's not frequent. Okay, so if you take the 3 item set, what you have generated previously, what are the 3 item sets you have generated? So only these 2 will satisfy. These 2 are not frequent. So BCD and ABC are the only 2 things which we have to see. Okay, so ABC we have already seen, it is closed and it's maximal. BCD is closed and it's maximal. Okay, so then ABCD, it is not frequent. So finally, so with that further we cannot move. Okay, that's all. We had only 4 items. So this is the last step. So now you can see here, this is a total summary of what we have. So a total summary of 1 item set, 2 item set, 3 item set, and 4 item set. So you can see what are the frequent items, what are the closed items, and what are the maximal. Okay, so what are the maximal items here? Maximal frequent item sets. What are the items? Maximal items here. Look at the slide and tell me. Huh?
A, B, C, and B, C, D.
Very good. A, B, C, and B, C, D. Only tick mark is here and here. Okay. So maximal means its superset does not contain minimum support count. So yeah, this maximal will not give more information. Okay. But then closed is giving some more information. Okay. What information is giving? That ABC is frequent. So that's what it will give you some more information. And ABC has got a support count of 3. Okay, so by downward closure property, what we have just learned, you can say that all its 2 to the power k subsets are also frequent. Okay, so that's what. So basically, for association rule mining, closed property is being used, and it is not maximal property which is being commonly used. Okay, so that's what I wanted to tell you. So have you understood the difference between a frequent pattern, a closed pattern, and a maximal pattern? Yes or no? So with this understanding, you please work out this problem when I take attendance. So after I take the attendance, I'll ask one of you to give me the answer. Okay, so you have 5 item sets out here. The list of items are also being given here. The minimum support count is 40%. If minimum support count is 40%, what is the value of min sub? It's given in percentage. What is the value? What is the value? Can somebody tell me? It's given in
Ma'am, is it 2?
any other value. How do you get 2? Can you just tell me?
Ma'am, 40 into 5 because the number of transactions is 5. So by 100.
Very good. Yeah. Okay. So that's how you get it. Okay. You find the frequent item set, closed item set, and maximal item set. Okay. So you are doing closed mining and max pattern mining. Okay. So by the time I take attendance, you please do it and give me the answer. Okay. Okay, answer your attendance. Anirudh?
Present, ma'am.
Okay, I hope all of you have made a note of this. Right. Dharini?
Present, ma'am.
Ramharini?
Present, ma'am.
Now everybody are telling present, but when I ask you something in the class, no response. As Nishok was telling, madam is keeping on calling out names and asking. Correct, no, Nishok? I don't know which Nishok did that. Aravind, Kalyan Sundar?
Present, ma'am.
Aravind? Sharan Varghese? Sharan Varghese is absent. I'm not looking into the chat window. Somebody can tell me. Priya?
Chat
Priya.
box, ma'am.
Okay, so I should look into the. So can somebody take a picture of this so that I can look into the chat window simultaneously and put it in the WhatsApp group? Selvan Niklesh is there. Can you take a picture and put it in the WhatsApp group? Our rep will answer only on the next day. Anirudh, can you take a picture and put it in the WhatsApp group?
Taken, ma'am. Will post in.
Please
second.
post in the WhatsApp group. Yes. Okay, so that I can simultaneously check this also. Thank you. Okay. Who's it?
Nishok present, ma'am.
No, Nishok is present. I didn't reach there, I suppose. Okay. Next number is Nishok. Shreya.
Present, ma'am.
So far, I think only Sharan Varghese is absent, right? Okay, Lekita is present. Very good. Suveda.
Present, ma'am.
Vishal Bhashyam.
Present, ma'am.
Srimati S. Sorry, Srimati M. Okay, noted. Nityashri.
Yes, ma'am.
Pranavram.
Present, ma'am.
Srimati S. Srimati S. Registration number 46 is absent. Raja Singh.
Present, ma'am.
Pooja.
Yes, ma'am.
Lavanya.
Present, ma'am.
Nityashri.
Present, ma'am.
Sriramji.
Present, ma'am.
Sriramji has started doing,
Not yet, ma'am.
Why? No notebooks are open.
Ma'am, actually, I'm not feeling well, ma'am. I'm trying my best to listen.
Okay. You please take care. What
Okay.
about others?
Thank you, ma'am.
56 Nityashri has started working out the problem.
Yes, ma'am.
Yeah. Satyamohan. Okay, noted. S. Sharan. Sharan.
Present, ma'am.
Okay, present. You give me the attendance later. I will not be marking. Aviral Patel.
Present, ma'am.
Hemavartini.
Present, ma'am.
Ajay. Okay, noted. Akshata Saha. Akshata Saha is also noted. Karthik Balaji.
Present, ma'am.
Santosh Kumar. Santosh, no response. Anand Arun. 115 is present. Okay, Rahul P. noted. Suhasini Srikanth.
Present, ma'am.
Apurva Ravichandran.
Ma'am, ML, ma'am.
Apurva is ML. Okay. Right, Vitun.
Chat box, ma'am.
Okay. Adityan.
Present, ma'am.
Selva Niklesh.
Present, ma'am.
Ramcharan.
Chat box, ma'am.
Noted. Achinta Murari.
Present, ma'am.
Santosh Kumar.
Present, ma'am.
Pavitra Shri.
Yes, ma'am.
Praveen.
Present, ma'am.
Rakesh.
Present, ma'am.
Okay. Nityashri Narasimhan.
Present, ma'am.
Nishok Kadriven.
Present, ma'am.
Abel Prashant. Abel, okay, noted. Preetika, noted. Kevin Kurian Joseph.
Present, ma'am.
Kitain. No response, absent. Adya.
Present, ma'am.
Jevora.
Yes, ma'am.
Kishore. Okay, noted. Sridevi. Okay, noted. Yash Rai. Okay, noted. Where were you, Yash, when I asked you a question? Jayesh Kumar. Jayesh Kumar is absent. Okay. So anybody who has missed out attendance?
Ma'am, 020, ma'am.
What's your name? 020.
Sharan Varghese.
Sharan Varghese. Okay, noted. Anybody else?
Ma'am, Santosh Kumar has put in chat, ma'am.
Santosh Kumar, what's the number?
83.
Okay, Santosh also marked. Fine. Right, so let's get back. Anybody has finished working out the problem? Finished working out? How far have you completed? So Nityashri has told support count is 2. 40 into 5. 40%, 40 by 100 into total number of transactions will give you the value of your minimum support. Okay. Then what is the first step? First step is support count for individual items. Then check whether anything is there which doesn't satisfy the minimum support count. Then you generate 2 item set. Check whether it is closed or maximal. Then go for. Are you all getting the same answer? At least somebody tell me. Finally, this is what you're supposed to be getting. Are your answers matching with this? Any doubts in anything? Any of the steps? Are you all getting this answer? Did anybody get this answer? B is not closed, not maximal. Same case with E2. It's closed and maximal. B is closed, not maximal, whereas E is closed, maximal. M is closed and maximal. P is not closed and not maximal. 3 item set is empty. BP is closed and maximal. Okay, so this is the final result what you get. Okay, so shall I move on to the next one? Assuming that you people will complete the rest at home and there are no doubts. Okay, so yeah, this is all about close set. Close set is nothing but closed pattern mining. So this is a research paper which tells about these, which visualization for it using SGI mindset. Okay, so now coming to like which patterns are interesting. What are the various pattern evaluation methods? We have already discussed 2 pattern evaluation methods. Do you know what are they? Do you know what are they? What are the 2 pattern evaluation techniques or metrics that we have discussed so far? At least somebody, even if it's wrong, doesn't matter. What are the measures of interestingness of a pattern?
Ma'am, support and confidence.
Very good, very good. Who's the person who confidently gave me that answer? Who's it?
Me, ma'am.
who's this me? Nitishri. Okay, very good, Nitishri. So only one person is listening in the class. Okay, so the two measures we have already discussed. One is what is called as support, and second one is confidence, because most of the association rule mining algorithms employ this particular framework. Okay, but then this is not enough. Okay, so like there are some cases where the computing this support and confidence can mislead us. So in which case we need to look into a little more effective measure for discovering only the interesting rules. Okay, so that's the reason why we are going to look into what basically is the third one, called lift. Do you remember what was the support all about? Support we discussed how often a particular rule is appearing in the database which is being mined. That was what was support all about, right? When you say support of A to B, it's all about how many number of tuples are there containing both A and B divided by the total number of tuples. Okay, tuples is nothing but records. Okay, rows or records. Okay, or I think another formula which I had given us, support of A implies B means probability of A union B. This was another that is percentage of transactions in the database that contains both A and B. Okay, so basically support refers to the popularity of the product. It will tell you about the usefulness and certainty of the rule. Okay, so 5% of the transactions, when you say that 5% support is there, that means 5% of the transactions in the database is following the rule. So that's what you mean by support, the popularity of the product. Okay, so yeah, so that was what is support all about. What about confidence? What is confidence? The number of times a given rule turns out to be true in practice. Okay, so when you say confidence of A and B, this was already discussed. Okay, number of tuples containing both A and B divided by the total number of tuples containing the transaction A. Okay, so confidence of 60% means 60% of the customers who purchased milk will also milk and bread might also buy jam or butter. Okay, it refers to the possibility that the customers who bought both items, they are buying two things together. That's what is confidence. Okay, or in another thing what I told you is support count of A union B divided by support count of A. It can also be represented in terms of your conditional probability. P of B by A, all this was discussed. Okay, so if a rule satisfies both minimum support and minimum confidence means it is strong rule. But now we are telling that that's not enough. That is not enough to give you the interesting rules. Okay, so you need to take the help of one more measure, which is nothing but called your lift. Okay, so called lift. It is actually a simple correlation measure. It's a correlation measure. First, I'll give you a general example, then I'll give you a practical example of how a lift can be used. Okay, so what is lift all about? Okay, so this is it's a measure of correlation or dependency of events. Okay, lift of B comma C is equal to confidence of B to C divided by the support count of C, which can also be written in this fashion. Okay, so it will tell you how this items B and C are correlated. If the value is 1, then it means they are independent. If it is greater than 1, it means it is positively correlated. And if it is less than 1, it means it is negatively correlated. Okay, it is negatively correlated. Okay, so please make a note of it. What is the lift and how it is. Okay, so I'll give you an example. This is a very general example. So you can see here, calculating the lift for this particular rule, lift for B to C. It is nothing but what the thing says is confidence of B to C divided by the support count. Confidence divided by support count. Okay, so that's what you substitute the respective values. You substitute the respective values, you get this answer. Okay, so This is not C and not of C, B and not of B. This is a contingency table from which you can plug in the appropriate values and calculate the appropriate values of lift. Lift for this particular rule, B comma C, and lift for B comma not C. So here the lift is 0.89. Here the lift is 1.33. Okay, so if it is more than 1, it is positively correlated. If it is less than 1, it is negative correlation. This is negative correlation and this is positive correlation. Okay, so this is a very general example. So now I will give you an example for a lift computation from a supermarket transaction data. Okay, a supermarket transaction data. So I said lift is basically to identify the misleading rule. When you say a strong rule based on your support and confidence, it may not be that a good measure. Okay, there could be misleading rules. Okay, so this lift will help us to identify misleading rules. Identify misleading rules. Okay, so okay, I've not worked it out here. Okay, so let's take this example. Okay, the supermarket transaction data. So you have 10 transactions out here, T1, T2, T3, T4, T5 up to T10. Okay, and there are various items which are being bought together in all these, each of these transactions. Okay, so you have M stands for milk, D stands for diaper, BU stands for butter, BR stands for bread. Okay, so this is a supermarket transaction data. Okay, so for example, let's say you have a rule called rule R1, which says bread, comma, butter implies diaper. Okay, so this is the antecedent of the rule, left hand side, and this is the consequent of the rule, nothing but your right hand side. Okay, so let's prove that this rule is a misleading rule. Prove it's a misleading rule, that it's not correct. Okay, so yeah, so first what you will do is you try to compute the confidence of rule R1. What is the confidence of rule R1? Can somebody tell me? We have already learned how to compute the confidence. I hope you're able to see this Microsoft Word document, what I have displayed, and you're following it. Tell me yes or no.
Yes, ma'am. Yes,
okay,
ma'am.
fine. Yeah. Tell me what is the confidence of this particular rule? What is the confidence of this particular rule? What is my rule? Rule is bread, comma, butter gives you diaper. Okay, so confidence of this rule is number of transactions having bread, butter, and diaper. How many transactions are there having bread, butter, and diaper? Bread, butter, diaper is there here. Then bread, butter, diaper is there here. Bread, butter, diaper is there here. Okay, 3 divided by support count of bread and butter. Bread and butter is coming here. 1, 2, 3, 4, 5 places it's coming. So 3 by 5. Okay, so confidence of rule R1 is 3 by 5. What is the support of diaper? Support of diaper. How many places diaper is coming? 1, 2, 3, 4, 5, 6, 7. 7 cases out of 10 transactions diaper is coming. So this is 0.6. This is 0.7. So you can see here the support is greater than the confidence. Okay, so usually the pattern is the customer will be observing bread and butter first and then the diaper. But then as per this statistic, our support is more than the confidence. That is, popularity for product diaper is more than the, people are observing diaper more than bread and butter. So it is actually misleading. Okay, so we cannot put this particular rule in association rule for mining. Okay, so this is what is an example for a misleading rule. Have you understood? Here the support is greater than confidence. Okay, so the usual pattern is not being observed here. Okay, usual pattern is bread and butter and then the diaper. But then as per the statistics, our support is more than confidence. So this is an example for a misleading rule. Okay, so to correct this particular thing, we have what is called the lift. Okay, so this will basically lift the rule up to certain particular level. Okay, so what is the formula for lift? Lift is nothing but confidence of the rule divided by the support of rule. Support of rule, that is nothing but the consequent of the rule, that is our right hand side. Support of the rule is consequent. Okay, right hand side. Okay, so what is the confidence of the rule? Confidence we have computed 0.6. 0.6 is nothing but, let's say, 6 by 10 divided by what is the support of the rule? 7 by 10. That is okay. So okay, so I have computed my lift to be 6 by 7. Okay, so here what we have basically done is we have used lift to correct the support and confidence threshold. Okay, so it is not always true that support and confidence will give you a proper measure of interestingness. Okay, there you need to have some estimate in order to correct that. Okay, so that's what the practical aspect of lift is all about. Okay, so the support and confidence, both your support and confidence, both will have a value between 0 and 1. Okay, so it will always fit into this finite interval. Okay, including 0 and 1, it's a crisp set. Okay, it will always have a value between 0 and 1, whereas lift is always unbounded. It is like the lower bound can be 0, upper bound can be anything, so you can put it as infinity. Okay, so lift is always having a value, but it's not negative. Okay, there's no negative value for lift. Okay, upper bound can be anything. Okay, so that's what basically your concept of lift is all about. Have you understood? Okay, then there's some relationship between your lift, support, and confidence. Okay, already I have shown it in the PowerPoint. I'll just put it once again. Okay, so if confidence is greater than support, when I say confidence, it is confidence of rule. If the confidence of rule is greater than the support of the rule, okay, then the lift is positively correlated. Lift is positively correlated. Okay, so if confidence of the rule is less than the support, then lift is negatively correlated. Okay, or if confidence is equal to support, that is lift is equal to 1. That is, it is independent. Okay, so that's what I have shown you here. Basically here, see, I think here I had put it, yeah. See, independent, positively correlated, and negatively correlated. Okay, so that is all about your third measure of interestingness called lift. And this was a general example what I gave you to compute the lift. Okay, so another practical example what I gave you is from the supermarket data, where we had a rule. Okay, so where we had a rule. What was the rule? Bread and butter gives diaper. And then I said it's an example for a misleading rule. Why? Because here when we compute the support and confidence, support turns out to be more than the confidence. Okay, so people generally observe the pattern bread, butter, and then the diaper. But then here the statistics says that people observe diaper more than bread and butter, which is not true. So this particular rule cannot be used for association rule mining. Okay, so this particular rule cannot be used. Okay, so we need to have another measure of interestingness which will lift the support and confidence. For that purpose, we have what is called the lift. Lift is nothing but the confidence of the rule divided by the support of the rule. Support of the rule, that is the right hand side, the consequent. Okay, so wherein we calculate this as 6 by 7. Okay, support and confidence can have a value between 0 and 1, whereas lift can be, the lower bound can be 0 and the upper bound can be anything. Okay, so these are the respective relationships between support, confidence, and lift. Okay, so with that we come to an end of our second unit. Okay, so this was basically the last topic. Okay, so last topic of your second unit. So Tomorrow we'll have a test on second unit. How about having a test on second unit? Okay. The attendance was is 43 now, and remaining have left the class. So we'll have a test on this. It's basically 3 or 4 algorithms and the interestingness measures. That's all the second unit is all about. So with that, I'm stopping. Thank you.